Okay, let's look at a concept called multiplicity and how that affects the x-intercepts graphically. We'll see that our graph will either cross the x-axis at an x-intercept or actually touch the x-axis and turn around. It kind of does a bouncing thing on the x-axis at that x-intercept. Here's how we'll know if our graph crosses the x-axis or bounces or touches on the x-axis, and it's based on the multiplicity. And multiplicity just means how many times is that zero repeated. Multiplicity means repetition. If the zero has even multiplicity, if it repeats an even number of times, the graph touches the x-axis and turns around. If the multiplicity is odd, that means it occurs an odd number of times, then the graph is going to cross over the x-axis at that value. Let's look back at the previous problems we did, and let's state the multiplicity on each zero and see whether the graph would cross or touch the x-axis at that zero. What I've done here on this page is I've copied the results from the previous page. So here are the four problems we had. We had the zeros that we found for them, and let's just investigate further A. Okay, so we'll look down here at A. The final factors we came up with were x squared, a negative x squared, and an x minus 2, and an x minus 2. And that x minus 2 could be written as x minus 2 squared. So the two zeros we came up with were x equals 0 and x equal 2, if you look back on how we did that. What's going to be the multiplicity on each of these zeros? The multiplicity comes from the degree on the factor. So the factor that x equals 0 came from up here, there's that factor. The degree on that factor was 2, so the multiplicity on this 0 is 2. The degree on this factor that x equal 2 came from is 2, so the multiplicity is 2. That tells me graphically I'm going to bounce or just touch the x-axis and turn around. It touches the x-axis. Let's look at the results for C. I had a factor of x plus 1 and a factor of 2x minus 3. I ended up with a 0 of negative 1 and a 0 of 3 halves. Now let's go back and investigate the degree on each factor. The degree on x plus 1 is 1. So the multiplicity would be 1. It's an odd number. The degree on 2x minus 3, where 3 halves came from, is an even number. It's squared. The multiplicity is 2. The degree tells us the multiplicity. Now graphically, we'll cross the x-axis here because the multiplicity is an odd number. On this one, the multiplicity is 2, and that's an even number, so the graph will touch the x-axis at that value. Let's investigate D. We came up with zeros of x equal negative 1/2 and x equal 5. Now let's check out the multiplicity. What's the degree on the factor that a negative 1/2 came from? The degree was 2, so the multiplicity is 2. What's the degree on the factor that 5 came from? 3, so the multiplicity is 3. Now let's decide if it crosses or touches the x-axis. The multiplicity is even, it's going to touch the x-axis. The multiplicity is odd, it's going to cross the x-axis. I would suggest that you put those three problems in your calculator one at a time and investigate the graphs and see if the graph indeed touches or bounces off the x-axis at 0 and touches at 2. Same thing for each of these to just kind of validate that theorem that we looked at on multiplicity. Okay, so we just took care of this part. And kind of one last characteristic would be turning points. Remember, our graphs are nice, smooth, continuous curves. So we'll see curves that do whatever, maybe like that, or a couple of hills and valleys. These hills and valleys are called turning points. And the number of turning points will depend on the degree. So our turning point says if we have a polynomial function of degree n, then the graph will have at most n minus 1 turning points. In this case, my degree is 5. So I will have at most 5 minus 1, which is 4 turning points. That's the most turning points you would have if you had a 5th degree polynomial function. So you would only see 1, 2, 3, well, 4. I didn't really graph that one. Let's just graph one up here that would have 4 turning points. Let's say there's 1 turning point, 2, 3, maybe something like that, where there's 1, 2, 3, 4 turning points. That's the most turning points a 5th degree polynomial function would have. Now let's talk about how we're going to approach graphing polynomial functions. Let's go through our checklist. First thing is, let's figure out how the n's are going to behave. Second thing, let's figure out the zeros and the multiplicities. Find that y-intercept. Remember, that's always found by letting x equal 0. The zeros, we set the function equals 0 and either factor or do the quadratic formula, however that works. And then we're going to use the calculator to help plot curves. So that's why I went through the previous calculator work, so we can get these in our calculator and plot these polynomial functions. Let me see how many of these did not turn out. Okay, just that very first one. So let me pull up, if you bear with me. I'm going to pull this up right here, and it is, you probably have it on your sheet, I just don't have it handy right now, x to the 4th minus 2x squared plus 1. X to the 4th minus 2x squared plus 1. Alright, so there's our polynomial function, and we want to work on graphing this polynomial function. So let's think about the n behavior from this leading term. The degree is 4, so I should know how the n's are going to behave. How are they going to behave? Well, they're going to both go up. Because it's an even degree, so it's going to behave like x squared, and there's a positive number in front. So both n's are going to go up. How about that y-intercept? If I let all my x's be 0, I have 0 minus 2 times 0 plus 1, so the y-intercept is at 1. And I could work on finding my x-intercepts by hand. I could take that polynomial function, x to the 4th minus 2x squared plus 1, set it equals 0, and this guy actually factors. X squared, negative 1, negative 1. So I get an x squared minus 1 and an x squared minus 1, which again factors into x plus 1, x minus 1, x plus 1, x minus 1. Well, I'm seeing some of the same factors here, which will just give me zeros of negative 1 and zeros of positive 1, and each of those have multiplicity of 2. Multiplicity of 2, multiplicity of 2. Now we're going to let our calculator help us plot these curves, but at least we have an idea of what might be going on here. So let's see. Let me plot those positive 1 and negative 1 intercepts, and the y-intercept up here at positive 1. And what we'll do next is we'll pull out the calculator type that in and get an idea of what that's going to look like. All right, where'd my calculator go? Okay, come on. Should have had that up and running, but we'll take a look at it. Oh, that was back on our last example, huh? Well, let's go to y equals, clear out what we have there, and let's type in the x to the 4th. X to the 4th minus 2x squared plus 1. And let's do that in zoom 6 to get a decent picture of that. Oh, there's the picture of it. So what does it look like? Let me just go to zoom 4 and see what's going on. Yeah, looks like it's bouncing there, bouncing there. The multiplicity was 2, so I kind of figured that was going to happen. So we'll just connect the dots, use the calculator, and we'll get this W-shaped thing. Ooh, that's an awful graph. I'm sure you did a lot better job with it than I did. Let me change my direction here. There we go. So there's the graph of our polynomial function. So use your calculator to help you determine how to plot your curves. Now let me also show you something you can check on your calculator. Go to the table feature. Look at those values, -1, 0. Hey, there's an x-intercept that we found by hand. There's another one, +1, 0, one that we found by hand. So let the calculator help you in determining some of this information. Let's check out the next one. Let's grab some zeros. You know what? When it's factored like this, your zeros are much easier to find. If I said x plus 1 equals 0, I got a 0 of -1. This thing factors into x plus 2, x minus 2, so I get x plus 2 equals 0, x minus 2 equals 0, and so I get a -2 and a +2. So there's my list of zeros. This guy has multiplicity 2. These two each have multiplicity 1 because the degree was 1. So I should be crossing at these two values of 2 and touching at the value of -1. So I should touch, cross, and cross. We'll see if that happens. Oh, end behavior. Completely forgot about that one. When they're in the factored form, you don't really know what the degree is, but let's just think about it. This is saying the highest degree, if I FOILed that out, would be an x squared. If I multiplied this out, the highest degree would be a square. So what is a square times a square going to give me? It's going to give me a 4th power. So the degree is going to be even. And since there's a negative in front, there'd be a negative in front of that x to the 4th, so both ends should be going down. We'll see. Let's put that in our calculator and check out the graph of that. Let me go down a little bit. All right, so let's go to y equal, clear out what was there, and let's type in -3 times x minus 1 squared. Remember, use this little negative down here. -3 times x minus 1 squared. And what was the other part of it? X squared minus 4. Parenthesis, x squared minus 4. And let's go to zoom 6 and get a picture of that. So I see it coming up here, comes back down, bounces, and then crosses. And if I go to my table feature, I see there's a 0 of -2, 1 at 1, 1 at 2. It all kind of matches up with what I found by hand. So if we are going to graph this based on our picture here, let's come over here and do that. Alright, so I have 1 at -1. I had 1 at -2. Is that right? I don't remember it doing anything at -2. And then I had 1 at +2. Let me go back and check that picture out. +1, +2. Alright, where'd I mess up? That's it. Copy the sign wrong right there. That should be x minus 1, so that's a +1. Alright, so let me knock this one out. Yeah, I make mistakes too. So we said it was going to touch here at the positive 1, right there, and it's crossing at the negative 2, and it's going to cross at the positive 2. And both ends go down. So what we saw is something that went way out of bounds, but it eventually comes back down. It's going to touch there, came back up and cross. Now this is not the best picture, but it's just kind of an overview of what happens with this graph. Hopefully you would take a little bit more time and get a better graph of this, or I should say draw a better graph of your polynomial function. But again, we're using the calculator to let us determine where to place those curves. An awesome feature of that calculator is using the table feature. Use that table feature, second table, to see, oh, what are those x-intercepts? Can I find them from my calculator? So here's the assignment for 3.2. Some problems from the book. Work on the course compass stuff, but always go back and look at the applications and the technology. And now that you've gotten a little more practice with your calculator, go back and look at the technology problems.